Tell me in the comment box. Okay, so let us continue further, guys. Okay, so continuous time convolution, this is part 2. Now let us solve this question, guys. Based on the property, let us solve this question. See the solution of this question. Convolution of e to the power minus 2 t minus 1 u of t minus 1 convolution with u of t plus 2 is dash. Okay, so how to perform the convolution? So as I told you guys, first perform the convolution without any time shifting, that is, here t become t minus 1, here also t become t minus 1, here t plus 2. So without shifting, that means e to the power minus 2t into u of t convolution with u of t, okay, which is equal to, already we know that here answer of this convolution is 1 minus e to the power minus 2t divided by 2 into u of t, correct? Now next time shifting, here t become t minus 1, here also t become t minus 1, convolution with, here in this case u of t become t plus 2. So this is delayed by 1 second and this is advanced by 2 seconds. So here overall effect is what? 1 minus e to the power minus 2 here. Due to this t minus 1, so here t become t minus 1. Then due to this, guys, t become t plus 2, so it is plus 2 here, correct? Divided by 2. Okay, divided by 2 into here also, guys, here also you have to replace t with t minus 1 plus 2, correct? So the final answer I can say y of t is equal to 1 minus e to the power minus 2 here t plus 1 whole divided by 2 into u of t plus 1, clear? So this is the final answer. So in this way we can calculate the convolution between two signals. First of all, find the answer without shifting and then see how much overall shifting is present, correct? Now let us solve next question. Okay, now important concept, guys. So there are generally two methods. A previous question we solved using property only, okay, but if any question is there, then there are two methods to perform the convolution between two signals. Okay, one is graphical method and another one is analytical method. Okay, so we can solve all the most of the questions using analytical method only, because graphical method is very much lengthy and it's a tedious process, time consuming process. So it would be better to solve the same question using analytical method, and if it is not possible to solve any question with analytical method, then we can go for the graphical method. Okay, graphical method generally they are asking subjective type exam like ECE mains, in which it will be clearly mentioned that perform the convolution between given two signals using graphical method only. So in that case you have to use the graphical method only. But in GATE exam they are not mentioning any method, so simply we will solve, because MCQ type question or MSQ or NET, no subjective, So in GATE exam, simply we will solve using analytical method only, guys, and I will provide certain shortcuts also. Okay. So here linear time unit system, if input is x of t is given and system has impulse response h of t, then how to find y of t? So in time domain, y of t is equal to x of t convolution h of t, which is mathematically given by integration minus infinity to plus infinity x of tau into h of t minus tau d tau. Okay. As I told, there are two methods to perform convolution between two signals. See, x of t also one kind of signal, which is input signal, and h of t also one kind of signal, which is impulse response of the system. So both are signals only. So graphical method, analytical method. Okay, so we will skip the graphical method, as I told, guys. Why? Okay, so in graphical method, what you have to do? First you have to see, step number 1 is what? Find the range of x of t. Okay, find the range of y of t, that is lower limit and upper limit. Then change the axis t to t to tau, then time shifting, time reversal, then multiplication, the integration. So there are basically 5 steps in the graphical method, that also I will explain. See, here you can use x of t convolution h of t, or commutative property h of t convolution x of t. With the both method you will get the same answer. Okay, so if x of t convolution h of t, then you required x of tau and h of t minus tau. X of t and h of t both will be given, and from that you have to find x of tau and h of t minus tau. Correct? And if you are using h of t convolution x of t, then h of tau and x of t minus tau you have to find. Okay, so what is the first step? First step is what? Step number 1. Step number 1, finding the limits of y of t, or finding the limits of integration, we can say. Finding the limits of y of t. So here I am writing less than or equal to t. So what is the lower limit? So lower limit is nothing but what? Lower limit of x of t and h of t. Sum of the lower limit of x of t and h of t. So lower limit is sum of lower limit of x of t and h of t. Correct? And what is the upper limit? Again, upper limit is what? Sum of upper limits of x of t and h of t. Sum of upper limits of x of t and h of t. Okay, so what is the meaning of this step number 1? Okay, let us understand this step. Suppose this is x of t convolution with h of t, and here I am drawing the resultant signal y of t. Okay, let us consider this is one signal x of t, general signal. This is h of t, and here we will get the resultant signal y of t. Okay, correct? Okay, so this is x of t signal. We are performing convolution this x of t with h of t signal, and the resultant signal is y of t. Okay, now this signal has lower limit. Let us consider the lower limit is t1 and upper limit t2. That means we can say x of t has non-zero amplitude between t1 and t2, where t1 is the lower limit of x of t, and we can say t2 is the upper limit of x of t. Okay, similarly, let us consider this h of t has lower limit t3 and upper limit is t4. upper limit is T4. Now the resultant signal will have lower limit. Lower limit, let us consider this is the lower limit, which is nothing but, lower limit is nothing but sum of the lower limit of x of t and h of t. So here T1 plus T3, sum of lower limits of x of t and h of t. And the upper limit will be the sum of upper limits of x of t and h of t. So this is the upper limit, then it will be T2 plus T4. So of course, if this signal has length or width T1 and this signal has length or width T2, then this signal will have length T1 plus T2. Width of this signal is T1, width of this signal is T2, then width of this signal will be T1 plus T2. Correct? So this is the meaning of first step. Now next, as I told guys, you required x of tau and h of t minus tau, or you required h of tau and x of t minus tau. So here variable of interest is tau. So first of all, you need to change the x-axis from t to tau. So this is the step number 2. Step number 2. So what is this step number 2? We have to change the axis, or change the x-axis, we can say. Change the x-axis variable, x-axis from t to tau, t to tau. So that means here it should be x of tau and h of tau. Correct? Simply you have to replace t with tau, okay, in x of t and h of t. This is the step number 2. Now next you required step number 3. Now next we required, see, if you are using if we use first formula, then we require h of t minus tau, and suppose if you want to use the second formula, then we required x of t minus tau. Okay, so here h of t minus tau means what? See, h of t minus tau means here now variable is tau, not t. So minus tau plus t. So first left shift by t, you have h of tau, and from h of tau now we have to find h of minus tau plus t, and variable is tau now. Correct? Variable is tau. So here first left shift by t and then folding with respect to y axis, tau become minus tau. So here time shifting and time reversal. Next is what? Left shift and time reversal, we can say. Time shifting, that means left shift by t, time shifting and time reversal. Suppose you are using the first formula, then you got x of tau, now you require h of tau. So from h of tau you required h of t minus tau. So first of all left shift by, here left shift by t, correct, and then folding with respect to y axis, that is tau become minus tau. Correct? Tau become minus tau. Are you getting? So it is nothing but what? This is equal to what? H of t minus tau. So now you got x of tau as well as h of t minus tau. Correct? First formula. See, x of tau and h of t minus tau now we got. Then simply what? Multiplication of these two signal and then integration. Multiplication, then integration. Suppose if you want to use the second formula, then in second formula we require h of tau. So already we got, and now we require x of t minus tau. So from x of tau now we have to find x of t minus tau. So suppose second formula, then x of tau, and from x of tau it is x of left shift, again same thing, left shift by t, then folding with respect to y axis. So it will be x of t minus tau. So suppose if you want to use the second formula, then for that we got h of tau and x of t minus tau. And next step is multiplication and integration. Step number 4 is what? This is for the graphical method. Step number 4 is multiplication multiplication and integration. Step number 4. Multiplication and integration. That means what? Multiplication means x of tau into h of t minus tau, then integration, or h of tau into x of t minus tau. So here finally y of t will be, if you using the first formula, then minus infinite to plus infinite x of tau into h of t minus tau d tau, and if you are using the second formula, then y of t is equal to integration minus infinite to plus infinite h of tau into x of t minus tau d tau. Clear? Fine. I hope all the students are getting. So these are the steps to be followed in the graphical method, guys. Graphical method. Fine. Now as I told, we will not use the graphical method as it is a very lengthy process and time consuming process, and it's a tedious process. That's why. Now next is, let us come to the next method, that is analytical method. So in the analytical method, we can reduce the complexity of solving integration by the knowing the causality of the given signal, whether the given signals are causal or non-causal. Say for example, here we will say total 4 cases. Case number 1 is, suppose both are non-causal. If both are non-causal signals, then we cannot simplify the integration. Simply you have to follow this formula only, guys. There is no change in upper limit and lower limit. You have to follow this formula only. Y of t is equal to integration minus infinite to plus infinite x of tau into h of t minus tau d tau. We cannot simplify if both are non-causal. But suppose case number 2. Suppose x of t is causal in this formula. If x of t is causal and h of t is non-causal. So here we know that if x of t is a causal signal, x of t is causal signal, then for each and every causal signal we know that its amplitude is, its value is 0 for t less than 0. Now in our formula x of tau is there, so we can say replace t with tau. So x of tau is 0 for tau less than 0. Okay. So here an integration limit is minus infinite to plus infinite. But for tau less than 0, x of tau is 0. So integration answer will be 0 for tau less than 0. Okay. So here see, y of t is integration, tau is from minus infinite to plus infinite. Now I am splitting the limit. Let me split the limit. Minus infinite to 0, x of tau into h of t minus tau d tau, plus integration tau is from 0 to tau equal to infinite, x of tau into h of t minus tau d tau. Now see here, for tau less than 0, x of tau is 0 because it's a causal signal. Okay. So here x of tau is 0. X of tau is 0 for tau less than 0 because it is a causal signal. So x of tau is 0. So answer of first integration will be 0. So y of t will be, here in this case there is a change in lower limit, correct? Integration 0 to infinite x of tau into h of t minus tau d tau. Okay. So there is a change in lower limit. Lower limit will be what? Instead of minus infinite, it will be 0. So if x of t is a causal signal, then simply you can take integration from 0 to infinite, put the value of x of tau and h of t minus tau. Correct? So change in the lower limit. Here we can write there is a change in lower limit. Change in there is a change in lower limit. Fine. Change in the lower limit, guys. There is a change in lower limit. Fine. Okay. Now suppose x of t is non-causal and h of t is causal. In this equation, now h of t signal is causal signal. So as h of t is a causal signal, if it is a causal signal, then we can say h of t equal to 0. But in our equation, it is 0 for t less than 0. But in this equation, we require h of t minus tau. So here we can say h of t minus tau is 0 for t minus tau less than 0. Left hand side t become t minus tau, right hand side also t become t minus tau. So here this h of t minus tau is 0 for tau greater than t. So for tau greater than t, it is 0, guys. So again we can split this integration in two parts. See, this is tau greater than t. So minus infinite to t and t to infinite. Okay. So here integration tau is from minus infinite to t. Minus infinite to t x of tau into h of t minus tau d tau plus integration tau is from t to infinite. Correct? Greater than t, guys. Greater than t means what? T to infinite. X of tau into h of t minus tau d tau. Okay, h of t minus tau d tau. Now here, now we know that here for tau greater than t, h of t minus tau is 0, guys. So this is x of tau is 0 for tau greater than t. Tau greater than t. Okay. So y of t. Okay. So this is 0 for tau greater than t. So here this is t to infinite. Of course t greater than tau. Tau greater than t. So answer of second integration will be 0. Answer of second integration will be 0. So y of t will be here. We can say y of t will be minus infinite to t x of tau into h of t minus tau d tau. So we can see here there is a change in upper limit. In previous case it is lower change in lower limit minus infinite to 0, and here it is plus infinite and here it is t. So change in upper limit. Here there is a change in upper limit. Change in the upper limit. Correct? There is a change in upper limit. Okay, very good. Now last case, guys. Suppose both are causal. If both the signals are causal, see, if this is causal signal and this is also causal signal, so of course the y of t also causal signal, guys. Y of t will be causal signal. If both the signals are causal, then the resultant signal also causal, guys. Fine. The resultant signals also causal. Okay. Now see, if both the signals are causal, see x of t is causal as x of t is causal signal. As this is causal, so x of t is equal to 0 for t less than 0, correct? And here x of tau is there, so replace t with tau. So x of tau is 0 for tau less than 0. Fine. And h of t also causal. So h of t is causal, as this is causal signal. So h of t is 0 for t less than 0. And here h of t minus tau, so replace t with t minus tau. So it is 0. It is 0 for tau greater than t. Now see, x of tau is 0 for tau less than 0, and h of t minus tau is 0 for t greater than t. So in both the cases, the answer of integration will be 0. Less than 0, greater than t. Less than 0, x of tau is 0, that's why answer of integration 0. Greater than t, h of t minus tau 0, that's why answer of integration is 0. Now between 0 and t, guys, between 0 and t, both x of tau and h of t minus tau, both are non-zero. So that's why answer of integration also non-zero, guys, correct? So here we can say there is a change in both the limit. The answer of integration will be non-zero between 0 and t, guys. So simply what you can do, simply put the amplitude of x of tau and h of t minus tau and change in both the limits. Limit will be 0 to t if both are causal signal, 0 to t if both the signals are causal signal. So x of tau into h of t minus tau d tau. Okay, x of tau into h of t minus tau d tau. Fine. Clear to each and every student? This is very much important. If both the signals are causal, then the resultant signal also will be causal, and the change in both the limits, lower limit will be 0, upper limit will be t, guys. So here change in both the limits. So total 4 cases we have seen. Change in both the limits. There is change in both the limits, correct? Now let us solve some question based on this analytical method, guys. Okay, so first is convolution of step function with impulse function. So this is very much easy, guys. We know that convolution of any signal with impulse function is nothing but that signal only, like x of t convolution del t is equal to x of t. So here y of t will be what? Y of t. So u of t convolution with impulse function, it is nothing but what? U of t only, guys. It is a very simple, correct? And result is what? Important result. Suppose this is multiply with k1, u of t minus t1 and shift by t1 second. Okay, convolution with suppose k2, and it is del t minus t2. What is the answer, guys? So here k1 into k2, yesterday also we have seen k1 into k2, and u of minus t1 and minus t2. So t minus t1 minus t2, correct? U of t minus t1 minus t2. So this is the very much important result that you have to remember. So what you have to do, guys, remember only standard format without shifting. Remember without shifting. Okay, so you have to solve the question without shifting, and then you can apply final shifting in final answer, guys, like k1 k2 t1 t2 you can apply in the final answer. Fine. Okay, so question also we will see, don't worry. Next is very much important, convolution of step with step. Already we solved this question using differential property, if you can remember. Convolution of u of t with u of t is nothing but ramp function r of t, which is equal to t into u of t. Now we will solve this question using analytical method. Okay, so analytical method, it is y of t is nothing but integration minus infinite to plus infinite x of tau into h of t minus tau d tau. So y of t is equal to integration x of tau. So let us consider this is the x of t signal, so it will be u of tau. And let us consider this is h of t signal, so it will be u of t minus tau d tau, and here minus infinite to plus infinite. Now see, we know that u of tau, see, u of tau is equal to 0 for tau less than 0, and u of t minus tau is 0 for, already we have seen, tau greater than t, guys. Okay, so here see, this is 0 and this is t, guys, correct? So here u of tau is 0 for t less than 0, u of tau is 0, u of tau is 0 for tau less than 0, and u of t minus tau is 0 for tau greater than t, guys. For tau greater than t, it is 0, correct? So multiplication will be non-zero. Multiplication will be non-zero between 0 and t, yes or no? Here multiplication, see, u of tau is 0 for tau less than 0, so answer of integration is 0 for tau less than 0. U of t minus tau 0 for tau greater than t, so that's why answer of integration will be 0 for tau greater than t. So non-zero value between, here non-zero value between, in this case between 0 and t, u of tau into u of t minus tau is equal to 1, guys. Multiplication, here 1, here 1, between 0 less than or equal to t less than equal to, sorry, tau t. Clear? So if you replace u of t with 1 and u of t minus tau with 1, here if you replace this thing with 1, guys, then the limit will be 0 to t only, guys, correct? So here it will be 0 to t, and I told you, guys, as this is causal, this is also causal, so both causal, so limit will be 0 to t only. In this way also we can see. So here answer is tau 0 to t, and of course this is for what? Greater than 0, so we can say it is for t greater than 0, so answer is t for t greater than 0, and for, of course, t less than 0, answer is 0, so it is nothing but what? T into u of t, correct? And it is nothing but ramp function r of t. So finally we got here u of t convolution with u of t is nothing but t into u of t, which is r of t. T into u of t, which is nothing but what? R of t. Clear? Fine. Now here again observation. Again see, this is multiply with k1 and u of t minus t1, correct? Convolution with multiply with k2, and this is t minus t2, correct? So answer is, see, k1 into k2, k1 into k2 into, see, k1 to k2 into, here t become t minus t1 minus t2, here also t become t minus t1 minus t2, or we can write r of t minus t1 minus t2. So this is also very much important result, guys, correct? This is also very much important result. Is this clear, guys? Fine. I hope all the students are getting. Okay, now next guys, next now let us solve. Okay, already we solved this question, u of t convolution u of t, u of t convolution u of t. Now let us solve some question based on this. So see, here x of t convolution h of t equal to y of t, so you have to find the y of t guys. Two x of t and h of t signals are given and you have to find y of t, or you have to draw y of t graphically guys. Okay, graphically you have to draw y of t. So see, so first of all you can write this step function mathematically. You can express this graphical representation in mathematical representation. So see, this is x of t signal, x of t, step function with amplitude 2, step function, that's why u, correct, u of, now going towards right side, starting from 2 and going towards right side means plus t, and opposite side plus 2, that's why minus 2. So simply this is x of t. Similarly h of t is equal to, this is also causal, this is also causal, so resultant signal will be causal only. So it is again step function with amplitude 1, unit step, starting from 5 going towards right side, that's why u of t minus 5. Now y of t is, x of t convolution h of t. So y of t is equal to, this is 2u of t minus 2 convolution with u of t minus 5, u of t minus 5. So it will be, y of t will be, see, convolution of u of t with u of t is nothing but r of t, but it is u of t minus 2, u of t minus 2. So this is 2 r of t minus 2 minus 5 is. So answer is 2 times r of t minus 7, correct, r of t minus 7, fine. So it is, the resultant signal is what? The resultant signal is ramp function y of t. The resultant function is ramp function starting from plus 7 going towards right side, and the slope will be plus 2, that is increasing, slope will be plus 2 guys. Okay, so starting from 7 going towards right side, okay, and here slope is 7, starting from 7, and here slope is plus 2 guys. Now they can make it numerical answer type question also. So if x of t convolution h of t equal to y of t, then find the y of t value at t equal to 9, t equal to 5, at t equal to 10. Okay, so in this way they can make numerical answer type question also guys. Suppose here I'm asking find, I'm adding one question, also find y of t at t is equal to 10. So what is the amplitude of resultant signal y of t at t equal to 10? So at t equal to 10 guys, we want to calculate the output, or we can say y of t at t equal to 10. So at t equal to 10, let us mark this is value is p guys. So simply slope concept we can use, slope dy by dx, this is dy, this is dy, and this is dx guys. So slope is 2 guys, slope is 2, here I am writing, see, slope is 2, so dy by dx, what is the value of dy? So dy we want to calculate, dy is nothing but p, yes or no? This dy, this amplitude is p guys, and this amplitude 0, so p minus 0, dy is p. What is dx? Dx is nothing but what? Dx is 3 only guys. Simply have to take magnitude of slope, magnitude of dy, magnitude of dx, already we studied in the first chapter. So here value of p here value of p is nothing but 6 guys. Okay, so y of 10 is nothing but 6. Clear? So this is 6. So they can ask numerical answer type question also like this. Fine. Or they can make MSQ question also. Option A, this one. Suppose they are giving option A, y of t equal this one, and option B, y of 10 equal to 6. Now suppose asking y of 5. So y of 5 is nothing but 0. Correct? Y of 5 is nothing but 0 guys. Clear? Fine. Okay, very good. Now next this question guys. This is also in the same way we can solve. So try yourself question. Okay. So here y of t equal to a, x of t convolution h of t. So first x of t is equal to step function with amplitude 3 going towards right side, so t opposite sign here. Okay, and similarly h of t is equal to minus u of t minus 3. So y of t is equal to convolution of x of t with h of t. So y of t is equal to x of t. So 3 u of t plus 2 convolution with minus u of t minus 3. Now we know that convolution of u of t with u of t is nothing but ramp function. So 3 into minus 1. So here amplitude is minus 3. And ramp function t plus 2 here. And this is minus 3. So y of t will be minus 3 r of t minus 1. So the resultant signal is ramp function going towards right side and starting from plus 1 and with slope minus 3, decreasing slope. Minus 3 means decreasing slope guys. Okay, so the resultant signal will be see starting from plus 1 guys, plus 1 and going towards right side. So that's why for t less than 1 answer is 0. And decreasing slope, you can see here guys, here slope is minus 3, that means decreasing slope. So like this. Here slope is minus 3. Minus 3. Again, they can ask to find y of t at t equal to 5 suppose. So we want to calculate the amplitude at t equal to 5. Suppose t equal to 5 we want to calculate. So at t equal to 5, let us mark this is p guys. Okay, this is p. So again you can use the concept of slope. So this is dy and this is dx guys. So dy and dx. The slope is minus 3, which is equal to dy mod dy divided by dx is 4 guys. So dy is equal to minus 12 guys, correct? So this difference is minus 12. Here amplitude is 0, difference is minus 12. So it will be what? Minus 12 only, correct? So y of 5 is minus 12. So they can ask numerical answer type question like this. Fine. Y of 5 is minus 12. Clear to each and everyone? So this is very much important topic. Now next is this one guys. See, find output y of t of LTI system for the given input. Continuous time linear time invariant system is given, whose impulse response h of t is equal to u of t minus 3. Input graphically given. So find output. So how to find output? Output is nothing but what? Convolution of convolution of input signal h of x of t with impulse response h of t, with the impulse response h of t, guys. Correct? So here what is x of t, guys? X of t is nothing but step function starting from -1 going towards right side, amplitude 3. So it is 3 u of t plus 1, 3 u of t plus 1, and h of t already given in the question. H of t is equal to 2 u of t minus 3. So y of t is equal to 3 u of t plus 1 convolution with 2 u of t minus 3. So y of t is equal to convolution of step with step ramp, 3 into 2, it is 6, guys, r of t plus 1 and minus 3. So y of t is equal to 6 r of t minus 2. So it is a ramp function starting from -2 with the slope 6 and going towards right side. So this is 2 only, starting from 2 going towards right side. Okay, with the slope plus 6, that is increasing, guys, like this. Okay, and here value of slope is plus 6. Correct? Okay, so again they can ask numeric answer, they can make numeric answer type question, like they can ask a value of output at t equal to 3 or t equal to 4 or t equal to 10. Okay, now next is what? Convolution of step function with ramp. First we have seen impulse with impulse, then step with impulse, then step with step. Now ramp with step, convolution of ramp function with step function. So again analytical method you can use. So y of t is equal to integration minus infinite to plus infinite x of tau into h of t minus tau d tau. Okay, so y of t is equal to, here integration minus infinite to plus infinite, this is x of tau, so you can take r of tau, and this is x of t minus tau, so it is nothing but u of t minus tau d tau. Integration minus infinite to plus infinite, r of tau means tau into u of tau, and this is u of t minus tau d tau. Now again we can see here, see this is also causal, this is also causal signal, both causal, so limit will be 0 to t. Or we can see here multiplication, already we have seen this multiplication will be 1 only when tau lies between 0 and t, guys. So if you replace this with 1, then the limit of integration will be 0 to t only. So here it will be y of t integration 0 to t tau d tau. So y of t is equal to this is tau square by 2 and 0 to t only, and both the signals are causal, so resultant signal will be also greater than or equal to 0. So it will be y of t, answer is t square by 2 into u of t. So convolution of ramp with step function is nothing but t square by 2 into u of t. This is parabolic function, correct? This is the parabolic function. So what we can say here, conclusion is कि r of t with u of t is nothing but t square by 2 into u of t. Okay, so here k1 into r of t minus t1 convolution with k2 into u of t minus t2, correct? So answer will be k1 into k2. Here t become t minus t1 minus t2, so t minus t1 minus t2 whole square divided by 2. And here also guys, in u of t also it is u of t minus t1 minus t2 guys. Clear? Fine. Okay, so this thing you have to remember always standard format, this one, then shifting property you can use. Okay, linearity and shifting property. Now next is ramp with ramp function guys. Convolution of ramp with ramp function. Convolution of ramp with ramp. So again y of t integration minus infinite to plus infinite x of one signal you can take as x of tau, and another signal you can take as h of t minus tau. Okay, so here minus infinite to plus infinite, so this is r of tau and this is r of t minus tau d tau. Minus infinite to plus infinite, r of tau, that is tau into u of tau, and this is t minus tau, so it is t minus tau into u of t minus tau d tau. Now if you replace this with 1 and this also with 1, then the limit will be 0 to t, or we can say this causal, so limit will be 0 to t. Okay, so y of t signal will be integration 0 to t guys. See, integration is 0 to t, integration is 0 to t tau into t minus tau d tau, t minus tau d tau guys. Okay, now solve this integration and tell me answer in comment box. Okay, so here it is 0 to t. Now see, t into tau minus tau square d tau. Now see, variable interest is tau, so with respect to tau this t is constant, so we can take it outside the integration. So take t outside integration, so this is t integration 0 to t tau d tau minus integration 0 to t tau square d tau. Okay, so y of t is equal to t here, this is tau square by 2 0 to t, and here minus this is tau cube by 3 0 to t, and this is for t greater than equal to 0. Okay, chale, so here it is what, t cube by 2 minus this is t cube by 3. Okay, which is equal to what, t cube LCM, if you take LCM then 3 minus 2 1 and 3 into 2 6, so t cube by 6 into t greater than 0, that's why u of t, both causal, so usual signal will be causal, so that's why here u of t, guys. So convolution of one ramp function with another ramp function is nothing but t cube by 6 into u of t, t cube by 6 into u of t. Okay, so see the important result here, we got convolution of ramp function with another ramp function is t cube by 6 into u of t. Okay, into u of t. Now here k1 into r of t1 minus t2 convolution with k2 r of t minus t2, which is equal to k1 into k2 into t minus t1 minus t2 whole square divided by 6 into u t minus t1 minus t2, correct? Okay, k1 into k2 into t minus t1 minus t2 whole square divided by 6, guys. Is this clear? Fine. So this is also very much important result, guys. So till now we have seen impulse with step function, then step with step, then ramp with step, then ramp with ramp, guys. So let us make revision of all this. So see, already we know that convolution of del t with del t is nothing but del t only, then u of t with del t also u of t, then u of t with u of t with u of t, so it is nothing but t into u of t, which is nothing but the ramp function r of t. Next is u of t with r of t, guys. U of t with r of t is nothing but what, t square by 2, a parabolic function, t square by 2 into u of t, and just we have seen that ramp function with ramp function is nothing but t cube by 6 into u of t. Okay, t cube by 6 into u of t, guys. So this thing you have to write in your short notes. Okay, prepare short notes regularly for revision purpose. So these are the important results. Now in this you can apply the shifting property also, guys. Okay. Okay. So guys, in next class we will see the convolution of we will solve certain questions. We will solve certain question based on this result, and then we will see the convolution of exponential function with step function, exponential with exponential, and again we will solve certain questions, important questions, and then we will see the convolution of finite duration signals. Till now we have seen the convolution between two signals which are having a infinite duration. So what is the answer for the convolution of finite duration signal? Okay, so that we will continue in the next class. So all of you, thank you so much watching me live on Wallah English channel, and please provide your valuable feedback after completion of this session, and next part we will continue into subsequent module. Thank you guys, thank you so much.